Hello everyone. In today's video, we are going to try to prove this particular Boolean law that a plus a bar b equal to a plus b. So here we are going to discuss about the proof for this particular one. Okay. So first, before going to do this derivation, we'll just see this particular one using our truth table. Okay. So how it will be? How this thing will be in a truth table. So is it how we are telling that these both are equal, okay, as per the Boolean law. So if you see, if we write the truth table, right, 0 0. So how we will write? Just first fill up the things and we'll see. So this is just a simply R gate, right? So how it will be? If any one of the input is so high, it will make it as high, okay. So this we already know. And here if it is a plus a bar b, if a is high, it is becoming high, right? So it won't be, because it's R operation, so it won't depends upon the both the input. If one of the input is high, it will automatically make output as high. It won't depends upon the another input. So here also we will make this high, and this a is, sorry, this is a. If a is high only, we are making this as high. If a is 0, we are going to here, right? So if a is 0, and this, how would the a bar will become is a 1. So that time it's fully depend upon b. So okay, if a is 0 and b is 1, means how the, what is our output? Here it will be b, here it will be b. So the b is here, it's 1. So we are making this as 1. If the a is 0 and a bar is again 1, then the b also 0, means the output will become b. So this is how they are telling that both are same, okay. So from the truth table we can come to know these both are equal, okay. Now this is what they told already, this has been proven. So okay, how to prove this one, okay. So how we can, just simply by saying this equation itself, we can tell how I am telling, right. So if you see here, a is one of the input for the OR gate. Generally, what about the OR gate? We know if one of the input is, if one of the operand of the particular OR operator is high, it will make the output as high, right. So here this is another operator, and this a comma a bar b is the operands, okay, operands of this particular operator here. So this is our a plus a bar b. So our operator is here plus, okay. So how it will behave? If a is high, it will make output as high. Then this a bar is b, a bar b is high, output will high, output will be 1. Or a, there is a, here a is don't care, here a bar b is don't care. Here if a is 1, out will be high. So this is what our R operator, right? So okay, a is high means this is high, then definitely one of the particular, this one will be a only. So if this a is high, it will automatically make the output as high. It won't depends upon the another input. So here, from here our a will be coming here, but here the a bar b is 1, means we are telling this output as high, right? So okay, let's consider a bar b is high. To make that as high, definitely our a should be 0, right? Our a should be 0 to make this as high. If the a input is 0, this particular with respect to a, we told that it should be 0, and b also need to be 1 to make this as high. So when the a will become 0, a will become 0 to make this a bar as 1, right? So when it will become 0, that time, so definitely this is not playing any role that time. This is not playing any role at that time. So this is become 0. So one of the operator is 0, means the R operator, what it will do? It will just simply give this particular depends upon particular another one operand, okay. So that is what we have discussed, right? So if you see, a plus 1 will become a, but a plus 0 will become a. This is about the OR gate properties, right? So if one of the input is 1, it will automatically give the output as high. If one of the input is 0, it will just out to the another one input. That is what about the generally about the OR gate operation, right? So this is what we know. A plus 1 equal to this one, a plus 0 equal to this a. Okay, so from this one, what we can come to know, right? So let me just draw this one. Okay, so what we know already, a plus 1 becomes 1, a plus 0 becomes a plus 1 becomes 1, a plus 0 becomes a. Okay, this is one thing. Okay, so from this how we can come to know if a becomes high, the output will become high. If b becomes high, that time a should be 0 to make the output as high. That is what. If anyway, if a or b is high, any one of the things is high, definitely our output will be high. Okay, so this is what we'll just prove this using the derivation. Okay, so okay, a plus a bar b. Now what we want from the truth table, we come to know both are equal. So now we have to prove. So that time what they are expecting it to be a plus b. So this a can be that same as that, but the b, in this b, this a bar need to be cancelled, right? So for that, how we can proceed with this? We'll just include another one b term with a, just to and one another some properties we know, right? A plus a bar will be a 1 and a dot a bar will be 0. So how we are telling this one, these things is like if a is 0, definitely a bar will be 1. If a is 0 and a is 1, a bar will be 0. So definitely different product, different terms, different bits. If we just add, it will make it as 0, because any one of the things definitely will be 0. And here if any one OR gate, with respect to OR gate, any one of the input definitely will be 1. So the output will be 1. So here a plus a bar b, then how we have to cancel out the b product. So for that, we'll try with this one more thing. Here it is, right? 1 plus anything is 1. So we have to cancel out the b. So for that, what I am trying to tell is just add the extra term 1 plus b. So this will be 1, right? So a dot 1, here this also will add, a dot 1 will be a dot 0 will be 0. This we know, right? 1 into anything a and 0 into anything will be 0. So here we are adding the 1 plus b term just to cancel out the a bar b, the b in the a bar b. Okay, so it will be a bar b. So here we will multiply inside this a plus ab, it will become, and here it will be a bar b. So this a will be there, and see, since we have to cancel out the b, since we have to cancel out the we have to cancel out these terms, with only b we need to have. So we are just taking a b as a common and a plus a bar. So here a plus b into 1. A plus a bar is 1. So and here a into 1 is a. That means anything into 1 is that anything. So here is the proof for that a plus a bar b equal to a plus b. So yeah, this is the thing, right? So here if we have this one as a, like we have to eliminate, here we have to eliminate the thing b. So that's why we are coming with this. Yeah, this is the proof for this particular one. Thank you.